Welcome back to another video. Today we are going to talk about decision tree algorithm. Now, decision trees are powerful and interpretable machine learning models, but sometimes a picture can speak a thousand numbers, right? So let's learn how to visualize these trees step by step and get a better understanding of how they make decisions. So we are going to create a decision tree model, we are going to visualize this, and also we are going to talk about parameter tuning, which is really good for optimizing the performance of the machine learning models. Let's start by creating a dataset. I'm going to use make classification from scikit-learn. So I will say from scikit-learn.datasets import make classification. After that, I'm going to say import pandas as PD. And I'm going to create a dataset like X and Y. After that, I will say make classification. I'm going to give number of samples 500, and then I'm going to say number of features is going to be 2, and number of informative is going to be 2, and I'm going to set the number of redundant as 0. So after that, I'm going to have values like X and Y. So our dataset is ready to use right now. It's a binary classification problem since we have two classes 1 and 0. Great. So let's convert this to a pandas data frame for easier manipulation. I'm going to say data frame, and it's going to be equal to the pd.data frame, and I will say X, and I'm going to say columns are going to be feature 1 and feature 2. And I'm going to set data frame label, and I'm going to assign Y like this. And after that, I'm just going to call data frame.head, and here is my dataset. Great. Here we have two features, feature 1 and feature 2, and a label which is either 0 or 1. This dataset is suitable for a simple binary classification problem which decision trees excel at solving. Before we can train our decision tree, we need to split this dataset into training and testing sets. We need this step because we need to evaluate the model performances, and we are going to train our models on the training data, and we are going to test our models on the testing data. So I'm just going to say from scikit-learn.model selection import train test split, and I'm going to say xtrain, xtest, ytrain, and ytest. Then I'm going to say train test split. I will give x, y, and I'm going to assign test size like 0.2, which means that 20% of my dataset is going to be on the test set and 80% is going to be on the training set. So if I have 10 data points, 8 of them is going to be in the training test and 2 of them is going to be in the test set. So now let's move on to building our decision tree model. Building a decision tree model is pretty straightforward. With scikit-learn, we will use the decision tree classifier. For this purpose, we will say from scikit-learn.tree import decision tree classifier, and then we are going to initialize this like classifier is going to be decision tree classifier. Then we are just going to use .fit method, and we are going to train our model with training data. We have xtrain and ytrain. Great, our model has been trained, but how does it make decisions? That's what we are here to understand, right? So let's visualize this decision tree. To visualize a decision tree, we have various methods, but today we are going to focus on using the plot tree function from scikit-learn. So I will say from scikit-learn.tree import plot tree, and I'm going to import matplotlib.pyplot as plt, and then I'm going to say plot tree. I will give plot tree. I will give classifier. I'm going to say fill true, and I will give the features names like it's going to be feature 1 and feature 2, right? And I'm going to give class names to this like class names, and they are going to be 0 and 1. Actually, I'm going to give them in string format like 0 and 1. And after that, I'm going to say plt.show. And here it is. So it's a little bit small, so I'm just going to change the figure size like plt matplotlib dot figure, and we will say figure size is going to be, let's say, 20 to 10. And after that, we are going to see this better. Great, it's a little bit small, but not bad. We can just change this like 40 to 20 maybe and see what is going to happen. And it's not getting any bigger. So what we can do in here is, this one is for the copying this plot, and you can just press this for opening this in other side. And here it is. Now we can see it clear. Great. So as you can see, each node of the tree represents a decision based on the features. The tree starts from a root node, which is this starting point, and splits into internal nodes and leaves. The cover filling indicates the class label, and the closer the cover to one end, the purer that node is with respect to that class. Now we are going to talk about their elements. Like, I'm just going to open a random one, like let's just check this, and we are going to talk about that. Gini measures the impurity of the node. A Gini score of 0 means all samples at that node belong to a single class. Samples, the number of samples in the node. Value, the distribution of samples among the classes. And the class is the majority class label. So, that was our elements, and now we are going to get back on the coding side of things like this. So we have seen how we can visualize this decision tree, and now we are going to talk about hyperparameter tuning, which is going to optimize the model performance and get the best output. So there are several hyperparameters like maximum depth, which controls the maximum depth of the tree, and minimum sample split, the minimum number of samples required to split a node, and these hyperparameters can dramatically affect the performance of our model. We will use a method known as grid search to systematically try out combinations of these hyperparameters. Scikit-learn makes this super easy with the grid search cross-validation class. Let's import that. We are going to say from scikit-learn.model selection import grid search cross-validation, and then we are going to define the hyperparameters and their possible values. I'm not going to enter a lot of values in here. You can just extend these values, like we'll say parameters grid, and we are going to open a dictionary after that. It's the common usage. We will say maximum depth after that, and let's give it the values like 3. I'm going to open a list 3, 5, 7, 10, and you can extend this, like you can just enter 12, or you can just add 8 after 7 like this, but I'm not going to add in this tutorial. And you can also extend that values for getting a better performance, trying out more things. And after that, I'm going to say minimum samples split, and it can take values like, for example, 2, 5, 10. Again, you can extend these values. And now we are going to create a grid search model. So I will say grid search, and I will say grid search cross-validation. Estimator is going to be our classifier. We just set it in the place that here we have the classifier in here. Estimator is classifier, and parameters grid is going to be parameters grid, and let's set the cross-validation as 3. And then we are going to train the model like grid search.fit xtrain and ytrain, and here it is. So we are just going to display the best parameters like grid search dot best parameters, and here there are maximum depth 5 and minimum sample split 2. I'm just going to store them in a variable like best parameters, and I'm just going to talk about this code. After running the grid search, we get the best hyperparameters for our model. It tries every combination and evaluates them using cross-validation. This way we get the most optimized model. Great! Let's build our decision tree model again, but this time with the best hyperparameters we have just found. After that, we will visualize it just like before. I can use best estimator method from grid, but I will do it manually for you to understand the concept better. So what I'm going to say right now is, I will say classifier optimized, and I'm going to say decision tree classifier, and here max depth is going to be equal to the best parameters max depth, and after that I'm going to set minimum samples split, and it's going to be equal to the best parameters minimum samples split. So let's train this model like classifier optimized dot fit, and it's going to be like xtrain and ytrain, and here it is. So let's visualize this, the optimized decision tree quickly. For you to remember that code like plot tree, we will say classifier optimized. This time we will give field true. Feature names are going to be feature 1 and feature 2 again, and then we will say class names, and they are going to be like 0 and 1 again. So after that we will just say plt.show, and it's going to display in here. I'm sorry, there is a typo, so I'm not sure why that happened, but I guess it's not going to happen right now. Yeah, great. So also let's make it bigger, like plt.figure figure size, and let's give 20 to 10, and here it is. That was all for this video. Thanks for watching. I'm creating content about data science and programming. You can subscribe to my channel for more videos like this. Also, I have a full playlist of machine learning videos. You can just check them from my channel's playlist page. Have a great day.